Okay, photochemistry. In detailed discussion for lots of exams which are very important. So photochemistry is the basic concept. Okay, that should be depend upon many conceptual thinking. Okay, after that when we have cleared the all of the concept, we can easily predict pattern Wuchik reaction, noise type 1, noise type 2 reaction. We can approach other like cis trans isomerization. Okay, 1 2 alkyl shift, 1 3 alkyl shift, like many reactions. Okay, but before that we have to consider how the process can be go. Okay, in presence of photon energy. What is photon energy? Photon energy is nothing but that should be the energy h nu. Okay, that should be nothing but that is h nu, that is energy. And this photon energy comes from the concept of photosynthesis, where the green plant having the some structural features like chloroplastid, which having chlorophyll, and this chlorophyll can able to absorb photon energy or h nu from sunlight. Okay, so and this sunlight is used to produce glucose in the leaves or the green parts of the plant. Okay, and this glucose is the source of all over the creatures, humans, their food. Okay, and this produced glucose is used for all of the body of the plant, and the rest that should be kept for future reference in any particular body, in any particular part of the plant. Okay, by taking the plants or part of the plants as a food, we consume this energy. Okay, and due to food chain, that is one creature eat plants and other creature eat those creature who eat plants. So by this way, from one topic level to other topic level, energy transmitted. Okay, by this way all of the world consume energy. Okay, world means all of the creatures in the world. Okay, so photo energy is very much essential to predict many photochemical reactions and also to understand photosynthesis process in bioinorganic or bioorganic process, and also cis trans isomerization. And for medical concept, we can understand the vision of our eyes, all of the things that should be correlated to photochemistry. Okay, now we consider what is called photochemistry. Okay, photochemistry is the study of reaction which occur in a system as the result of illumination of UV or visible radiation. So most of the cases photochemistry that should be concerned about UV and visible radiation. UV means 200 to 400 nanometer and visible means 400 to 800 nanometer approximately. Okay, so this energy, okay, due to this result of illumination, the reaction that should be occur, and for study we have to need some chemistry view, some chemical view, and this is termed as photochemistry. Okay, in photochemical reaction the molecule and atoms are activated by the absorption of photon. Suppose when there is no absorption of energy is there, so there should be in that position, that is the ground state where atom belong. Okay, but after absorbing H nu, that is photo energy, it get jump to first excited state or maybe further other excited state. Okay, so by this way, any ground state atom or molecule or electron that should be promoted in the higher excited state by absorption of photon. So therefore, photochemistry is the study of the effect of the radiant energy on chemical reaction. Only in chemical reaction due to radiant energy, the effect is called termed as photochemistry. Okay, the rate mechanism by which the reaction are either initiated or affected by the ultraviolet visible radiation. Sometimes the reaction may be affected, sometimes the reaction may be initiated. Okay, due to photochemistry. Okay, since for all practical purposes light radiation ranging from 2000 to 8000 angstrom, what we say 200 to 800 nanometer UV visible region, if we consider in angstrom unit, we have to say that is 2000 to 8000 angstrom. Okay, nothing but if we convert nanometer to angstrom, we get same value, that is 2000 to 8000 angstrom. Okay, so mainly concerned in bringing about photochemical change. So we can define photochemistry as the study of chemical effects. Okay, that should be produced by light radiation ranging from 2000 to 8000 angstrom, because when chemical reaction perform, there should be most of the cases UV visible region, that is 2000 to 8000 angstrom or 200 to 800 nanometer, that is very effective, and due to this some reaction can be happen, initiated or affected. This phenomena is termed as photochemistry. Okay, so the absorbed radiant energy provide activation energy. Okay, for processes which would occur very much more slowly or not at all in the dark at the same temperature. Sometimes many reactions which are not normally happen, or in dark reaction or room temperature does not happen at all, or if happen with slower rate, but when we introducing some amount of photon energy or UV visible radiation, the reaction can be occur with faster rate. Okay, so by this way we can say photochemistry is valuable in chemistry. Okay, and always consider, we have to remind activation energy. What is activation energy? Activation is nothing but to activate the molecule we have to give some energy. Due to this energy, the reactant goes in excited state or get excited, then to produce product. Okay, otherwise product formation or chemical changes does not occur. As for example, if we draw energy diagram, that is, suppose reaction coded, that is the reactant. Okay, and that should be the product. Obviously product get more stable, so less energetic, so energy gap that should be more under of the reactant. Okay, so that means products gets more stability. The reaction is exothermic, heat released. Okay, now always consider these energy, these energy are termed as threshold energy. Okay, threshold energy, that is the minimum amount of energy after that the reactant goes to react. Okay, now consider what is activation energy. Activation energy to go that transition state or transition point, this is called activation energy. So we have to mention threshold energy and activation energy are not same. Threshold energy is this. Okay, threshold energy is this amount, and activation energy is black. Okay, black in color, that should be activation energy. Okay, by these two we get product. Okay, now we consider the subject of photochemistry deals with chemical reaction that are dependent on action of visible or ultraviolet light, right? So from Planck's equation, E equal to h nu and h nu equal to hc by lambda, where nu is the frequency and nu always proportional to 1 by lambda, and due to this we get nu equal to c by lambda. Okay, c is the velocity of light, value 3 into 10 to the power 8 meter per second, and we can say 3 into 10 to the power 10 centimeter per second. If we convert meter to centimeter, we can get this value. Okay, so nu equal to c by lambda. C is the velocity of light, 3 into 10 to the power 8 meter per second or 3 into 10 to the power 10 centimeter per second. Lambda is wavelength, nu is the frequency. Okay, by this analogy we get that is E equal to h nu equal to hc by lambda. That is h value 6.626 10 to the power minus 34 joules second. If we need arc, that is must be 6.626 10 to the power minus 27 arc second. Okay, that is h value 6.626 10 to the power minus 34 joules second or 6.626 10 to the power minus 27 arc second. Obviously joule goes to SI and R goes to CGS. Okay, CGS system. Now consider photosynthesis process. This is termed as photosynthesis. Photosynthesis occurs, there should be 6 CO2 that should be react with 6 H2O in presence of light to produce glucose and emit 6 O2. Okay, 6 CO2 plus 6 H2O that should be react in presence of light, we get glucose and 6 O2. So glucose is the source of our all of the creatures, source of our food, and 6 O2 that should be the source of oxygen. By this oxygen we are alive in world. Okay, now there are two key features of photochemical reaction which give them special importance over thermal reaction. First one, the reaction takes place in the excited state of the molecules having a large excess of energy. Okay, so compound to ground state. Okay, it is often possible to effect reaction which are thermodynamically unfavorable, that is thermodynamically unfavorable due to their ground state reactants. Okay, so actually thermodynamically unfavorable reaction are not normally occur. Okay, due to ground state phenomena. But as we know, for photochemistry or photochemical reaction, the molecules or atoms or ions, they got excited and goes to excited state. So due to this, there should be possibility is there to produce thermodynamically unfavorable product. Okay, so there must be a chance to produce thermodynamically unfavorable product can be produced by this way. Okay, thermally may be not produced, but photochemically may be produced. Thermally may not be thermodynamically, most of the cases thermodynamically unfavorable products are not formed, but photochemically can be formed. Due to why? Because molecules or atoms, they get excited. Okay. Second one, the reaction are usually carried out at low temperature so that the products can be formed in cold, as the energy can be given from radiation, UV or visible or photo energy. So that's why extra temperature are not needed so much. Okay, so that's why cold temperature can be favorable. But for thermal reaction, there should be extra heat, extra temperature, extra energy have to be provided. Okay. So hence it is often possible to make highly strained ring system by pumping out excess energy as light to overcome the activation energy barrier in their formation. Normally strained system are not produced, but by photochemical reactions strained system can be produced. Okay. So normally thermodynamically unfavorable strained system, they are not produced, but photochemically they can be produced. Now we consider some law. First one, Gotas-Dapper law. Okay. Light absorbed by a molecule can be effective in bringing about chemical change. When light absorbed, due to this the molecule get excited, so due to this some chemical changes can there. Okay, but if there is no chemical change, so this absorption is not effective. Okay, so Gotas-Dapper law suggests that light absorption can be take place, but light absorption is only effective when this absorption gives some chemical change, otherwise not. Okay, this law was enunciated by two scientists in 19th century, 1900 century. Okay, 19th century. They found that all the light that was incident on a sample was not effective in bringing about a chemical change. Now they tell us that the radiation that should be incident in some substance material, they are not always effective. They are not always produce chemical changes. Okay. According to the Gotas-Dapper law, also called, this is called principle of photochemical activation, because this should be concerned about photochemical activation of molecules, atoms or electrons. Only that light which is absorbed by system can bring about a photochemical change that should be effective. Okay. So sometimes by absorption of light, the molecules gets excited. Maybe they collide to each other. By collision, some energy can be removed. By phosphorescence, by fluorescence, by ISC, by IC, by vibrational cascade, so many processes can be there which are not chemical change, which are physical change. Okay, so by this way energy can be lost. So that's why this absorption is not effective in that sense. Okay. Expression, it is important to note that it is not necessary that all light radiation absorbed by the reacting system will always cause chemical change. That does not so. Okay. Sometimes, as for example, when we do any good work, or when we always try to better result for our upcoming exam, and day or night we will study a lot, but sometimes we do not get a good marks what we expected. Okay, sometimes there might be the question is uncommon, might be we are ill in during examination, or might be we lost some time due to some many things can be happen, many reasons are there. So for any reason we do not get the expected marks what we imagined. Okay, so similar things. So when absorption takes place, all absorption are not effective because all absorption are not produce chemical changes. Okay, as we effort in examination, we day or night we can study a lot, but maybe we get good marks. Most of the case we get good marks due to our day or night study, but sometimes we do not get our expectation fulfillment. Okay, so atoms molecule can absorb radiation only to re-emit it as line or broad spectrum of same or other frequency. Okay, sometimes atoms molecule they absorb radiation and re-emit the line or broad spectrum of same or another frequency. So under this condition, absorption light does not change any type of chemical reaction, that should be completely emitted. Okay, the law is purely qualitative. Qualitative means what? We know there should be two terms, that is one is qualitative and other is quantitative. Okay, quantitative. Okay, qualitative means that should be are not concerned about amount. Okay, exact amount, but quantity, that should be always concerned about the amount. Okay, now does not give any relationship between the amount of light absorbed by a system and the number of molecules which that should be reacted. Okay, now let I0 is the intensity of light that enters in the medium. Okay, now constant I0 is nothing but that is intensity of light that should be entered in medium. IT is the intensity of transmitted light that should be transmitted from the materials. So intensity of light absorbed, that is IA, that should be actually absorbed, that should be total intensity of light that should be entered, I0 minus transmitted light, that should be IT. Okay, so following cases may arise. First one, for substance other than solution or gaseous, intensity of transmitted light is given by the Lambert's law. That is IT equal to I0 e to the power minus KL. IT equal to I0 e to the power minus KL. L is the thickness of the absorbing material. K is the absorption coefficient. Okay. So IA equal to I0 minus, now it put it in this equation. Right. So IA equal to I0 minus I0 e to the power minus KL. So when we taking common I0, we get IA equal to I0 1 minus e to the power minus KL. IA equal to I0 1 minus e to the power minus KL. So case 2 for solution or gases. Case 1 concerned about substances other than solution or gases. Substances other than solution or gases. Now we consider solution and gases particularly. So given by Beer's law, IT equal to I0 e to the power minus epsilon Cl. IT equal to I0 e to the power minus epsilon Cl. Epsilon is the molar extension coefficient. C is the concentration of the solution or gas. Now L is the depth or thickness of absorbing material. Okay. For instance, when radiation from a highly intense source such as suppose laser fall on a molecule, the latter can absorb even 2 photons simultaneously. Okay. On that case, when laser radiation can be incident in any materials, there should be 2 photons, not 1 photon, 2 photons simultaneously absorbed. So for such biphotoning, multiphotoning effect, Stark-Einstein law, that is the another law, should be modified. Why modified? We have to learn about it. That is Stark-Einstein law. Stark-Einstein law say that the amount of radiation absorbed is generally limited to 1 quantum per molecule taking part in a reaction. That is, radiation should be always 1 quantum per molecule. One molecule absorb 1 quantum only. Okay, 1 molecule absorb 1 quantum only. So by this way, this is the modification, because there should be 2 photon, 3 photon, biphotonic, multiphoton can be absorbed by lesser radiation. But actually Stark-Einstein law concerned about 1 molecule absorb only 1 photon only. Okay, so that's why Stark-Einstein law modified is told. Okay. Now Stark-Einstein law, this law also called as principle of quantum activation, because that should be concerned about quantum. Okay, first one, Cortez-Lapper law, is called photochemical activation. That should be concerned about photochemical change. Okay, and this law, that is Stark-Einstein law, is called quantum activation, because that should be concerned about quantum. Initiated by great scientist Stark in 1908 and Einstein 1912. Okay, the 2 scientists applied the concept of energy quantum to photochemical reaction. Okay, suppose nu is the frequency of radiation that should be absorbed. Suppose this radiation is O and this incidency is nu. Incident frequency is nu. So then the corresponding quantum energy absorbed per molecule will be, for 1 molecule absorb each nu. Okay, so the energy E absorbed per mole of the reacting substance, so that should be equal to Na h nu. per mole, that is NaH nu. So we can say NaHC by lambda. Okay, NaHC by lambda. Where c is the velocity of light and lambda is wavelength. The quantity E, that is the energy absorbed per mole of the reactive substrate, is called basically Einstein. Okay, the energy absorbed per molecule, that should be this term, is called as Einstein. This term is called Einstein. Okay, and it is evident that its numerical value varies inversely as the wavelength. Okay, that should be varies inversely with wavelength. This E value is Einstein. And if light absorbed, the shorter the wavelength and the greater is the energy absorbed. So as we know, energy is inversely proportional is lambda. If this energy is called as Einstein, so when lambda increases, so energy that should be decreases. When lambda decreases, energy that should be increases. Okay. Now we consider quantum yield. Okay. Up to this, we know that the yield means what? Yield means the product that should be obtained. Okay. Percentage of yield when we measure the yield in percentage. Okay. So when we do in lab performance, we react some reactant with reagent and produce some product. Okay. After purify, after column chromatography, after crystallizations, after so many thin layer chromatography, so many process, after NMR, IR, measurement, last we get pure product. Okay. So this pure product that should be measured in weight machine accurately. So now the product weight can be measured and this weight is termed as yield. That should be experimentally founded yield. That should be experimental yield. Okay. And when this yield we convert it in percentage, we get percentage yield. That should be experimental percentage yield. Okay. And also in some book, when you get the process of product formation for a particular reactant, there should be given the data about the yield of the produced product. Okay. This is called theoretical yield. Okay. And when this theoretical yield convert into percentage, we get theoretical percentage of yield. Okay. But for photochemistry, we concern about quantum yield. So obviously quantum yield means some related to quantum. Now that should designate as phi. The quantum yield of a photochemical process is defined as, that is, phi equal to number of molecules reacting or formed. Maybe they react or they are formed. Maybe number of molecules, if we consider about reactant, so they should be, so on that case we termed as phi equal to number of molecules that should be reacting by number of quanta absorbed. And if we concerned about the product formation, so phi equal to number of moles formed by number of quanta absorbed. Okay, both terminology can be used. If we consider reactant, so reactant obviously dissociated when going time. So phi equal to number of molecules reacting by number of quanta absorbed. And when we concerned about product formation, the product obviously formed. They are not dissociated normally. So phi equal to product formed by number of quanta absorbed. Phi is rarely unity, that is 1 is very much rare. In practice, its value varies from 10 to the power minus 2 to 10 to the power 4 or more. Okay, 10 to the power minus 2 to 10 to the power 4 or more. In photophysical view, the quantum yield can be defined as phi equal to number of moles react by number of Einstein, that is NH nu, that is overall E value, that should be absorbed. So phi equal to number of moles that react by number of Einstein of radiation that should be absorbed. We can also say similarly for product formation, that is phi equal to number of moles of product formed by number of Einstein of radiation absorbed. Okay, but this equation is not so much important. Most important this we can, that is moderately important, that should be moderately important, that is not so much important. That is phi equal to rate of process by intensity of light absorbed. Rate of process means nu, that is B, and by intensity of light absorbed, that is I absorption. Okay. The number of quanta absorbed, friends, that should be measured by some instrument, is known as actinometer. Okay, which is reaction system for which the quantum yield is known. Okay, by this way we can measure quantum yield. From energy photon quantum, we for one particular photon, the energy that should be h nu. For 1 mole equal to n molecules. N molecules means what? That is 6.023 into 10 to the power 23. That should be designated as Avogadro number n. Okay, so for one particular mole we get h nu. So for n number of particles, we get ultimately energy equal to nh nu. For one quantum we get energy h nu. So for